Hey, Julian.
Hey, Rhett.
How are you doing?
I'm doing well. How are you?
I'm well, thanks.
Great.
Are you excited to be in week 7?
I am so excited that this is the final week.
Well, as much as I love statistics, I do understand.
Yes.
Oh, looks like you're the first and for now the only uh, person in our meeting. So the floor is yours. What would you like to work on?
Actually, I did really well on chapter 12 items. I feel like I kind of comprehended most of the concepts pretty well. I'm mostly anxious about the final. The last exam that we took, I ran out of time, and I've
Yeah.
never ran out of time on a test before in my life. So I'm a little stressed about that situation repeating for the final.
Hmm.
So, do you have any input on how to prepare and get ready and maybe manage my time during the test taking portion?
Um, my short answer is is no. Only because so I haven't seen your final, so I don't know exactly what is going to be on there, or the length of it, or so I don't know. Here's an idea. Why don't you tell me about the last test? Tell me about like the format and like some of the questions, uh, and then let's think about what happened there and maybe how that might apply to the final exam.
Yeah, that's a great question. I feel like I paced myself well. And then I was only maybe 5 questions in and realized I only had an hour left in the time.
Hmm.
So I feel like maybe it's taking me too long to figure out what type of formulas to use on the question so I can do all the computations to find the answer.
Hmm. So, how many questions were on your last test?
I want to say 30 or 34.
And you had 2 hours.
Correct.
Um, and let's see. And so you said you were maybe, what did you say? Several
Yeah.
questions in.
Yeah, just a handful.
Uh-huh. What what are there any restrictions on the materials that you're allowed to have
No,
handy? Like,
no.
yeah. Well, and let me ask you one other question. Are you trying to use any kind of technology, like even if it's just like a basic calculator, um, or uh, and if so, what type of uh, calculator or technology are you using?
I have a T184 calculator. I'm also just using the calculator on my phone because it has all the exact same functions.
Yeah.
And, and I've created an Excel spreadsheet. So whenever we need to find, the variance, the mean, and all of that, I have a spreadsheet already done with my formulas already calculated. So all I have to do is input data points.
Oh, okay. Now that's a really good idea, because I think the calculations are time consuming,
Yes.
depending on the technology you're using. So I think you're really smart to kind of have that all a plan and have that set up. And I really think personally that using like Excel or
Mm.
your TI-84, um, that you can do that faster than if you're just using a basic calculator. So as far as the time saving um, mechanism, yeah, I think that having a plan of action as far as like your technology is really good. Um, so let's see, you've already done that basically. One thing I would recommend, especially going into this, to the final exam and these last few sections, which are mostly about hypothesis tests. I guess I would, also recommend maybe having a list handy of the different types of hypothesis tests that you all have studied, and how you can recognize when a certain test is appropriate, and having kind of a roadmap of like how you'll conduct that particular type of hypothesis test.
Okay.
And so the tests are multiple choice, right?
Correct.
I think another thing, as far as if timing is an issue, and especially on a multiple choice test, I just think generally a good test taking strategy then is to, in some situations, not be focused on finding an exact answer, but rather being able to eliminate answers that couldn't possibly be correct.
Okay.
So, and I think, if you start to get into, get to a point where if you have, 30 questions or more, and you have 2 hours, so 2 hours, that's 120 minutes divided by 30 questions. So basically, you've got like 4 minutes per question.
Mm-hmm.
I almost think it might be helpful to, after you get to a certain point where you've invested, 4 or 5 minutes, to maybe just take a step back and look and see if you've done enough work where you can eliminate, 3 out of the 4 responses. And, or maybe you can just reduce the number of possible choices from 4 to 2, and then take an educated guess. And then, if you have time at the end, come back and see if you can do some more work to, decide from 2 good choices when you've already eliminated maybe 2 bad choices.
That makes sense.
I don't feel like I'm, as far as test taking strategies, I don't know that I'm the best resource. So I'm just telling you, those are some things that I do personally.
Okay.
But that's not, as far as like those strategies, that's not really my expertise, I guess you'd say. So, okay. I do have another suggestion though. If you can take like a practice, is there a practice test that's available to you?
I have not come across one.
No, and I don't think I've seen one on the course page, but I would speculate. A lot of these introductory statistics courses, it's very similar material. They almost all cover the same topics. I would bet you could find just a basic kind of a final exam for a typical introductory statistics course. And I bet that would be, not as obviously it's not going to be exactly the same of what Dr. White will give, but I bet it will be similar. Okay. And I found that if you take a test once, like a practice test, and if you can, give yourself the same parameters. So if you know that on the actual test, you're only going to have 2 hours for 30 questions. Maybe you can find a practice test that's, about 30 questions, also multiple choice, and just give yourself a time limit. And I really just, in my experience, people, if the second time you take a test, you do better, not just because you've seen the material before, but I think it just kind of relieves some of the anxiety that you've already been through this once. You kind of know what to expect. So you might look online and see what you can find.
Okay, that's a great idea.
And then, if you can, while you're taking that test, I would kind of note, like how much time you're spending on a particular problem. And it might allow you to identify, where you should focus in preparing for the final. So, for instance, if you realize, the hypothesis tests are, taking you like 10 minutes to do one, whereas maybe something else, like doing a confidence interval, maybe you're doing that faster, then you can kind of decide like where you're going to invest your time in studying. And then also you may just kind of realize that strategically, maybe that some of the questions are just too, or to know when to like just abandon it. It's like, like I'm spending too much time on this problem, and typically these take me like 10 minutes to work out, and I've only got 30 minutes left. It's going to be better off if I can do 3 of these other type of problems as opposed to this one that is more time consuming for me.
Yeah.
Yeah.
That makes sense.
So yeah, I think like finding like a good practice test could help with that.
Okay.
Now, with that being said, so you said that you've already completed the homework for the last section?
Yes, I haven't submitted it, but I have completed it.
Uh-huh. Well, I mean, looking back over the course, what do you feel like are your strengths? And, were there any kind of concepts that you think were more challenging that you could?
The p-value, for some reason, that was just a little more tricky than just doing just an equation problem. So anytime a question came up where it was like, do the test, find the formulas, make a decision and summarize your result, and then it would follow up and then be like, oh yeah, now let's look at the p-value and make an assumption based on that. The p-value always kind of stumped me on what to infer from the data that I collected.
So let me just take a stab at that. I might be able to give you some help. So the critical value and the p-value are very closely related. And maybe if I can kind of show you that relationship between the critical value and the p-value, that'll help kind of clear this up.
Okay.
So I'm going to just kind of draw a sketch here. And I'm just basically drawing like a normal curve. And I'm going to just do this based on like a standard normal distribution, but just note that this also applies if you're using a t distribution.
Okay.
A t distribution is also bell-shaped. It's also centered at 0. So just like the standard normal distribution, the same picture applies to both. So I'm going to do the first picture with the standard normal distribution, and then if we have time, we'll do one where we're using the student's t distribution.
Okay.
Okay, so here's my basic picture. So I'm just drawing a bell-shaped curve, and in the center, so this is where the z score is 0, right in the middle. Now, on the top, I'm putting a label. So there's the symbol mu, which stands for the mean of a population. and I'm putting a little subscript. I don't know if you can see it, but there's a little 0.
Yes.
So I would call this mu naught. Now this is the value of the mean that's assumed in your null hypothesis. So let's just say you had a null hypothesis I've added here that the mean is 75, okay? So the assumed center of this curve is at 75. Now, let's just say that you're testing an alternative hypothesis, a claim, that the mean is just something different. Actually, I'm going to just, hold on one second. Before we do a different, I'm going to say the mean is less than 75. So, that's our alternative hypothesis, is mean is less. Okay. Now, if we're doing a hypothesis test for a single sample and we're using the z distribution, that would imply that we know something about the population standard deviation. And so I'm going to just write on here, sigma equals 15. So that's an assumption about the population standard deviation.
Okay.
So let's say that we go out and we collect our data, which is like the evidence that we're going to use to make a decision about this. And let's say that we get from a sample of, let's say 25, we find a sample mean of, let me think for a second. That we find a mean in our sample of 68. So let's proceed as if we're going to do the hypothesis test using the critical value method.
Okay.
For that, we're going to need a level of significance, alpha. And let's just use 5%. That's a pretty common one, pretty standard. Can you tell me, I don't know if you have your table handy, but can you tell me what the critical value would be?
Yes. So looking on table E,
Yes.
I'm looking for a Z value that's closest to 0.95. So it would put it between 1.64 and 1.65.
Yes. Okay.
My critical value would be 1.65.
1 point. Oh, yes. Now I'll tell you. Often, people they'll interpolate, and so it's in between 1.64 and 1.65, and so they'll just kind of average those. And so it's common when you're using a 5% level of significance to say that the critical value is 1.645. Now, that's splitting hairs. In this example, it's not going to matter. So let's just say 1.65.
Okay.
Now, let's think about what that critical value means, and especially let's think about visually in terms of our picture. So I've added a few things to my picture here. So the critical value of 1.645, basically it separates off an area underneath that curve. The area is about 5% of the total area under the curve. And so this line, it separates 5% from 95%. Now, you realize that because you mentioned that you were going to look up 0.95 or find the closest thing to 0.95. What I want to point out here is, in our test, we decided that, well, I said basically that this is going to be a less than claim, that the mean is less than 75. So notice that I drew my line here that corresponds to the critical value on the left-hand side. And another thing I want to point out is that the critical value that you gave me of 1.65, notice I automatically changed that to negative.
Okay.
Do you know why I did that?
Yeah, because it's less than, so it's going to go left of center.
Yeah, and that's obviously, so remember that the z-score that corresponds to this middle is 0. So anything that's to the left is negative, and anything that's to the right is positive. Since this is a left-tailed test, it's a less than statement. Yeah, I'm drawing my critical line on the left-hand side, and I'm automatically changing that critical value to a negative value. Now, again, so that's where we're at. Now, what we need, if we're using the critical value method, is to find a test value to compare to the critical value. Now, have I given you enough information that you could calculate that test value for me?
I believe so.
Okay. I think I have. So let me give you a minute.
So I came up with a negative 2.33.
Excellent. That's exactly what I came up with too. And so I'm going to just because some other people might watch this later, I want to just kind of show the formula and the calculation. So this is the formula for my z test value. So there's an x bar, that's the sample mean, minus mu, that's the assumed value from the null hypothesis. In this case, it's 75. In the denominator, I have sigma, that's the population standard deviation, over the square root of n, which is my sample size. Now here I've filled in the values, 68 minus 75, 15 over the square root of 25. This all simplifies to negative 7 over 3, and that is approximated by negative 2.33. Okay, so let's go back to our big picture here. Remember, this line is our critical value, negative 1.65. Now, our test value is somewhere to the left of that. So at negative 2.33. So basically, this tells us that the results from our sample are in what we call the rejection region. So if our test statistic falls anywhere in this case to the left of that critical value, this is the rejection region, and we're going to reject the null hypothesis. So the decision here is definitely we're going to reject H naught, the null hypothesis. Now, let's think about how we would find the p-value for this test. Do you have any ideas?
Yes and no.
Okay. What are you, well, let's start with the yes. What, and don't worry about whether it's right or wrong. Let's just tell me what if you have some idea about how this relates to p-value and how we can now find that p-value.
I think we would take the Z amount and subtract it from 1 and then find that amount in table E.
So the Z amount, so do you mean the negative 2.33?
Yes.
Okay.
But that really doesn't sound right.
Well, I'll tell you what, that's, there are a lot of moving parts in this. Now, I will just say, keep in mind that a p-value is a probability. So that's what kind of where the p comes into play. You know, and probabilities are always going to be between 0 and 1. Some people prefer to use percentages, so that would be between 0% and 100%. So, you know, 100% means it's guaranteed, it is absolutely going to happen. 0% means it's impossible, it could never happen. The probabilities exist in that range, from 0 to 1. So when you're subtracting from 1, that involves a probability. So keeping in mind that, so earlier, for example, you did this. When I said alpha is 5%, you actually looked up 95%. So you were subtracting from 1, and correctly so, when you did that. Now in this case though, when we're working with z-scores go from negative infinity to positive infinity. Now we often only consider z-scores between approximately -3 and +3, and notice even in table E, they only go from about -3.5 to +3.5. So they don't go from 0 to 1 like probabilities, they go from negative infinity to positive infinity. So you won't be subtracting z-scores from 1. That applies to probabilities. So we don't need to subtract from 1. Rather, we are just going to look up the z-score that we found, that -2.33, and we're going to find the probability that's associated with it. So can you find that for me?
Yes. Is 0.0099.
Okay, yeah. So I want to point out something here. So what you found is the probability of getting a z-score less than -2.33 is approximately 0.0099. Now, how does that relate to our original picture here, and in particular to the critical value and the test value? So I'm going to move my, my picture back over. Now remember, here was the line that I drew for the critical value. So that was at -1.65. The darker line I drew to represent the test value. So that corresponds to -2.33. The probability that you looked up is the area that I've kind of darkened here that's to the left of that -2.33. So I'm going to add a little something to my picture here. this is 0.0099. And basically, I'll say that 0.0099, that's the area underneath the normal curve that exists to the left of. So that's why I do this little arrow here. So this line is the negative 2.33, and that's the area or the probability that's to the left of that. Now, what's the area or the probability that's to the left of this line, our critical value?
That is the 0.05.
Exactly. Perfect. Awesome. Now, let's focus just on, I'm going to just even fold my paper in half. I want to just focus just on this part of the picture. And let's look at how things are related. We were given this level of significance, 5%. And we found our critical value by looking up, well, you actually looked up 0.95, so you subtracted from 1. You could have also looked up just 0.05, and you would have directly found the negative 1.645. So you looked up 0.95, and then we just automatically changed it to negative.
Okay.
Either would have worked. Okay. So anyhow, I point out this line and this critical value of negative 1.65, that was based on this level of significance, alpha. Okay.
Okay.
Then we found a test value, and that's this line, which we figured out was negative 2.33. And then we looked up a probability associated with that z-score and found 0.0099. Now, we already knew that our test value was to the left of our critical value. And notice that also means that this probability is necessarily going to be less than 0.05. You know, from here over is 5%, so this has to be less than 5%. Now, how much less? Well, specifically, it's 0.0099. That's your p-value.
Okay.
So the p-value is the area to the left of the test value. The critical value, or alpha, is the area to the left of your critical value. So you can either compare line to line and say, what is this to the left of that? Or you could just compare probabilities. Is this probability less than that? But this probability is tied to this critical test value, and this probability is tied to that critical value. So whichever method you use, the critical value method or the p-value method, you're going to get the same result, because the level of significance determines the critical value, and the test value determines the p-value. So you can either compare z to z or alpha to p.
Okay.
But one determines the other. So it doesn't really matter. There's no really reason to do both. It's redundant, but it is a good idea when you're first learning to understand them both. But they are always going to give you the same conclusion.
Okay.
And so just understanding, and Julian, I'll tell you, I'm going to go back to your original question about test taking advice. This isn't just for tests, but this is just for statistics homework in general. A picture is worth, I don't know, more than 1,000 words.
Yeah, it really has helped a lot figuring out how to draw the picture and where things relate. And then it's like, well, now the calculations make sense because I can almost see it by just putting in the data points. So
And
that has been helpful.
Honestly, if I didn't draw a picture, I would make mistakes Drawing the picture allows, well, first of all, I'm a visual person, so, but that kind of allows me to see connections. And I would just, if if you take nothing else away, then please take away the value in just drawing a picture. It makes things so much easier, I think. Hey, why don't we do, since we have the time and it's also just us, why don't we redo this problem
Okay.
as a t-test? Julie, the only thing I'm going to change, I'm going to make one little erasure and kind of substitution. I'm going to see if you can see this. Originally, I had labeled the standard deviation using the symbol sigma, which would indicate that is a population standard deviation. Now I erased that and I replaced it with an S. So the S indicates to me that this is sample standard deviation. And so given our small sample size, it's no longer appropriate for us to conduct a z-test. So we need to switch gears and we need to do this as a t-test. So level of significance, I'm not going to change. We're going to leave that at 5%.
Okay.
The things that are going to change here are the critical value and the p-value. And I want to see if you can find those for me.
Okay.
Let's start by finding the critical value. Now remember, when we were doing a z-test, the critical value was negative 1.645. I'm sorry, we just decided to round it to negative 1.65. So let's see how that changes when we do a t-test.
So with the t-test, you're also going to need to know your degree of freedom.
Correct.
Which is n-1, which is going to be 24.
Yes.
Which now we're going to be using table F.
You're correct.
And this will be a one-tail test.
You're right.
So it will be 1.711.
Now, can you show me your picture and label, draw me a curve, tell me what's in this middle, and tell me where your critical value is and how that relates. Just show me what any information that you can provide.
Okay.
Now, I'm just realizing actually that your video is not on, so I'm not going to be able to see
Okay.
what you've done, but that's okay. Let me just show something and see if you agree. So I went ahead and drew a bell-shaped curve. and I put a line down the middle. Now in this case, I'm labeling that as t equals 0. And then I drew a line here, and this is the line that separates the bottom 5% from the top 95. So notice I just labeled that as alpha equals 5%. And do you see I put a negative in front of this?
Yes.
Yeah, once again, this is on the left-hand side, and so we'll just change that from positive 1.711 to negative 1.711. Okay, now, what about our test value? So that's a critical value.
So our test value is going to be the same as our z.
Yeah, you're right. This is the same formula. Basically, the only difference is we're using s over square root of n for the symbols. But as far as the end result, we still get negative 2.33 with a repeating decimal. Now, let's go back, and again, I'm going to just kind of cut this in half. So here was our critical value, negative 1.711. Now, where should I draw a line for the test value?
Further to the left.
Yeah, yes. And so somewhere, and I'm not going to worry specifically about where it is, but just somewhere to the left, I'm going to draw another line, and that corresponds to negative 2.33, which is my test value. Okay. Okay. So I've added that line. So somewhere over here, I do another line. There's negative 2.33. Now the p-value is going to be the area that's to the left of negative 2.33. How do I find that?
Well, I don't know.
This is trickier, for sure. Okay, let me help you out here. If you go back to table F, and if you look in the row that corresponds to 24 degrees of freedom.
Okay.
This is where you found the value 1.711. Okay. Now, I want you to look, so I've actually just copied down the entire row. And we want to find, where does 2.33 fall in this list of numbers?
Okay.
And don't worry about the negative part. It's just, in that row of numbers, 2.33 falls between 2.064 and 2.492. Does that make sense?
Yes.
Okay, so now let's look up. Now remember, we were doing a one-tailed test. So look up and find the one-tail alpha that corresponds to 2.064.
It's 0.025.
And what about for the 2.479?
0.01.
Yes. Yeah, excellent, good job. So what you've just found is that our test value falls between these two critical values. And these two critical values correspond to basically 2.5% and 1%. So I'm not able to give you a very accurate p-value, but I can tell you this. The p-value is somewhere between 1% and 2.5%. Now, I don't know specifically what it is. I'd have to use technology to give you a more accurate value for the p-value, but that's okay. All I really cared about was whether or not it was less than 5%. Well, if something's between 1 and 2.5, it's certainly less than 5. And notice, let's go back to our picture. When we were using the critical value method, we already knew that our test value was in the rejection region. It was to the left of our critical value. Now, it's not surprising then that this probability in this left tail is less than 5%. Now, again, I don't know exactly what it is, but it's somewhere between 1% and 2.5%. And that's enough for me to make the correct decision that I'm going to reject the null hypothesis. So, that p-value may be 1.2, it may be 2.3, it may be 1.79. I don't know. I just know it's between 1 and 2.5. Or if you're using decimals, it's in between 0.01 and 0.025. If I am really concerned about it, then I'll get out my calculator or go to Excel, and I can give you a much more exact number. But it's really not worth my time, because in order to make the decision, all I need to know is that the p-value is less than alpha.
Okay.
So I don't know what it is. It's somewhere between 1% and 2.5. Everything in that range is less than 5%. I mean.
That makes sense.
And go back to your picture again. Think about the connection between the critical values and the test values. In this case, we're using a t-test. Last time we did a z-test. But do you see the critical value is determined by alpha, and the test value determines the p-value. So these two things are related, and these two things are related. Again, you can either compare line to line or area to area. Pick one, but you're going to get the same result.
Okay. Yeah, that helps a lot.
Julie, I'll tell you another thing. Going back to test taking, if you draw a good picture, you're going to know the conclusion of the test without doing any calculations, or, well, with minimal calculations. As soon as we found out that in the previous example, well, I'll just say, just looking at this picture, I know what the conclusion of the test is going to be. We're going to reject the null hypothesis, and there's insufficient evidence to support the claim. Without even figuring out the exact p-value, the picture just kind of tells you, what your end result is going to be, and that can be a time saver. If the test question only asks, are you going to reject or fail to reject? I already know we're going to reject, and I could have told you that even earlier. Oh, while we're on this, And before we run out of time, I want to give you one more hint that I
Okay.
think can help you with your test taking. Let's go back to the first example where we were using the standard normal distribution. So I'm going back to this.
Okay.
Keep in mind, so in this case, your standard error is sigma over square root of n. Now, in that case, so this was the denominator when we were calculating our test value. So it was 15 over the square root of 25, which is 3. Now, give me 1 second to just draw off a couple things here. Another helpful thing to add to your picture, again, I'm just going to try to just show half of this. So the center here corresponds to a z-score of 0. Now, my standard error is sigma over the square root of n. In this case, it's 3. So if I go 1 standard deviation to the right, I would add 3 to 75. If I go 2 standard deviations to the right, I'd add 3 again. So that would take me from 78 to 81. If I add 3 a third time, I'll get 84, and that will correspond to positive 3 standard deviation. You could do the same on the other reverse side, where we add lines. I'm kind of messing up my picture here. It's getting messy, but I just want to also say that you could take 75 and subtract 3. So let me point out here. So 1 standard deviation over would be, and this is going to the left, that's 75 minus 3, so 72. If I subtract 3 again, I'll get 69. If I subtract 3 again, I'll get 66. So basically, when I was testing the hypothesis and I realized that my sample mean was 68, I already knew that 68 is somewhere between 2 and 3 standard deviations away. I don't know if that's helpful or not, but I mean,
Yeah, that's really helpful.
You can get more detailed in your picture, and if you invest that time up front, it can save you some time in the end. Time for making mistakes, or you may even just be able to skip some steps. So, anyhow, I hope that's helpful.
That was very
Well, I think that we're about out of time. And so good luck on your final exam. And I hope you've enjoyed the course and that I've been able to be of some help. And yeah, good luck to you.
Yeah, thank you. I appreciate all your help. You have been lots of help. And I've kind of enjoyed stats, but I'm really glad it's going to be over this week.
Well, you know, I don't expect to make to proselytize or convert people in their first course, but all right. Well, have a good night, and thanks for joining me.
Thank you.
My pleasure. Bye-bye.